Welcome to the Copperfield Electric Podcast.
Glad to be here.
Today, we are immediately pivoting away from our usual format. We're taking a deep dive into two really critical source documents you shared with us.
That's right.
Our mission is direct. We are extracting the essential need-to-know knowledge. The goal is to safeguard your exterior electrical outlets from, well, their biggest enemy, rain and moisture.
This is such a fundamental topic, and it's one that, often gets overlooked until there's a problem.
Right, until something goes wrong.
Exactly. Unlike the controlled environment inside your home, anything outdoors, especially your power sources, is subjected to a constant barrage of environmental stress. So we're going to distill the specific hardware and, more importantly, the code requirements, specifically the National Electrical Code, or NEC.
Okay.
That's what turns a simple outdoor plug-in point into a safe, secure, and reliable power source.
Okay, so let's unpack this then. We rely on these outdoor outlets for, well, everything. Charging our equipment, pressure washers, those festive holiday lights. They are absolutely crucial.
You really are.
But if they're designed for the outdoors, why are they fundamentally such a major vulnerability when water gets introduced?
It all comes down to physics, really. Even the slightest crack or an unsealed joint allows moisture in.
And that could be direct rain or even just condensation.
Right, direct rain, snowmelt, or, even heavy condensation. Once that water infiltrates, it acts as a conductor. It dramatically lowers the resistance between the conductors that are supposed to stay separate.
So we're talking about more than just, the simple rusting of the metal contacts, which is something you can see.
Oh, absolutely. Rust and corrosion, those are the long-term degraders. They physically damage the metal components, sure. Oxidation, electrolysis, it eventually renders the outlet unusable.
But what are the deeper, more immediate electrical dangers?
The immediate life-threatening danger is the short circuit and the ground fault. When water bridges that hot conductor to the neutral wire, or even worse, to the ground path or the outlet casing itself.
Yeah, the metal box.
Exactly. You've just created an unintended high current pathway.
And if someone happens to touch that casing or if water pools beneath it?
That's where the catastrophic risks lie. Electric shock, which can be fatal, and electrical fires.
Right.
When a short circuit generates that intense heat inside a wall cavity or against flammable siding, especially if the circuit protection is slow, the risk becomes very, very real.
So protecting these isn't just about making sure your leaf blower works.
Not at all. It's about maintaining the integrity of the whole system. It's about safeguarding the physical structure of your home and the people inside.
That context is vital. This isn't a nice to have, it's a mandatory safeguard.
Correct.
And that's why we immediately hit the National Electrical Code, which governs these installations. Protecting these outdoor points isn't voluntary, is it?
No, it's not. The NEC provides explicit guidelines. We're dealing with definitions of damp location versus wet location.
And an outdoor outlet is pretty much always a wet location.
Almost universally, yes.
Okay.
And that requirement demands specific protective measures. Things like weatherproof enclosures and, critically, installing ground fault circuit interrupters. This compliance ensures every outlet has robust, redundant protection built right in.
This brings us perfectly to the solution side of this deep dive. We've established the why, and it's a severe why. Now let's look at the how. Our sources emphasize there are three distinct lines of defense that have to work together. So here's where it gets really interesting. Let's start with that physical barrier. What's the first line of defense?
The first line is that external physical shield. It's the weather-resistant outlet cover, often called an in-use or a bubble cover in technical circles.
Okay.
These are crucial because they block the physical intrusion of rain, snow, irrigation spray, all of it.
I think a lot of people probably visualize those simple spring-loaded flaps, the ones that just cover the receptacle when nothing's plugged in.
Right.
But if you're using your holiday lights or a charging cord, that flap is wide open. It's useless. Are we talking about a different standard entirely?
Absolutely. The NEC distinguishes between covers for damp versus wet locations. If that outlet is in a wet location exposed to weather, you must use what's called an extra-duty weatherproof enclosure.
An enclosure that stays protective even when a plug is inserted.
Precisely. These are those deeper, usually opaque or gray plastic covers. They're designed to shield both the outlet and the plug connection at the same time.
So if I have a plug sticking out in the rain, the cover has to create a protective seal around that entire connection. That's a huge difference from the old simple flip cover.
It is a huge difference. If your current outdoor outlets only have that basic flick-up cover and you plug something in, you are violating the safety requirements. The internal electrical components are instantly exposed.
So what should people look for?
You want to look for covers with a NEMA 3R rating. That confirms they're built to withstand falling water and even external icing.
And I assume these wear out.
They do. If you notice any cracking, warping, or if that foam gasket on the back is damaged, that cover has lost its primary defense capability. It needs immediate replacement.
That distinction between cover when closed and cover when in use is a powerful piece of knowledge, but, like we said, even the best armor can be breached. So what's the second absolutely critical layer of internal protection? The failsafe.
That is the ground fault circuit interrupter, the GFCI.
Right.
This is the life-saving detector. It's required by the NEC for all outdoor receptacles. It's the essential redundancy system that works on a completely different principle than the physical cover.
We've all seen the test and reset buttons on these outlets, in kitchens or bathrooms, but let's get into the mechanics. How does a GFCI detect a hazard so fast that it actually prevents a shock?
It's remarkably smart technology. A standard circuit breaker, it only trips when there's a massive overload or short circuit. We're talking hundreds or thousands of amps.
Okay.
A GFCI is different. It measures the tiny difference in the current flowing out on the hot wire and the current flowing back on the neutral wire.
Meaning what exactly?
In a healthy circuit, those two values should be identical. Perfect balance.
Got it.
If the GFCI detects a differential as small as 5 milliamperes, that's 5 milliVA, a fraction of the current needed to cause serious harm, it instantly knows. It determines that current is leaking out of the system.
And that leak could be through water or worse.
Or worse, through a person grounding the circuit. When that 5 milliVA trip threshold is hit, the internal mechanism shuts off the power in milliseconds.
Real second.
Fast enough to prevent ventricular fibrillation, which is the cause of most electrocution deaths.
That speed and sensitivity, that's what makes it mandatory. So let me challenge this a bit, just to explore the nuance here. If I install a really high-quality bubble cover, one that meets that NEMA 3R wet location requirement, and my outlet is tucked safely under a deep eave, is the GFCI still strictly mandatory? Or could I argue that the physical protection is enough?
That's a great question. And the answer, based on the code, is absolutely unequivocal. The GFCI is still mandatory.
Oh, exceptions.
No. The NEC is not interested in arguments about how good your eave is. The code defines the location as outdoor, which mandates GFCI protection regardless of the physical cover or placement.
Because moisture is always a possibility.
Always. Even heavy humidity and condensation can trigger a fault over time. It's designed as a redundant, non-negotiable safety layer.
That confirms it. GFCI is the price of entry for outdoor electrical safety. So we have the cover for protection and the GFCI for detection. What about the third defense? The one that relies on, well, common sense and strategic planning.
That would be proper outlet placement. While all this hardware is designed to withstand the elements, you never want to force it to operate under maximum stress all the time.
So location selection is part of the safety design.
The critical part.
Where are we specifically trying to avoid putting them?
Well, you want to minimize direct exposure. So install receptacles in naturally sheltered areas, under deep eaves, inside recessed parts of a porch, or well beneath a patio roof. These spots protect the outlet from direct, wind-driven rain and heavy snow. But more importantly, you must avoid placing any outlet near major water sources where splashing is just inevitable.
Like pools or hot tubs.
Exactly. Pools, hot tubs, complex irrigation systems. The closer you are to a potential flood or splash zone, the higher the sustained risk of moisture saturation.
It sounds like a kind of passive defense. You're using your home's architecture to reduce the workload on your electrical defenses.
That's a perfect way to put it. Every layer of defense you employ, the placement, the cover, and the GFCI, makes the overall system exponentially safer.
So now, if the listener is realizing their outlets are, well, they're likely older, maybe not GFCI protected, or they have those useless flat flip-up covers.
Right.
The next question becomes about ongoing responsibility. We've covered installation, but what about long-term maintenance?
It shifts immediately from installation to diligent inspection. You have to treat these components as consumables. They degrade over time.
So regular visual checks.
Regular visual inspections are crucial, maybe seasonally, especially before and after periods of heavy rain or freezing temperatures.
What are the specific warning signs our listeners should be looking for?
The key indicators are any visible signs of water infiltration and the degradation that follows. Look for discoloration or rust, especially around the mounting screws or the casing itself.
And what if the GFCI trips a lot?
That's a huge red flag. If it frequently trips, that's a clear indication that water is getting in. You need to investigate the source of a moisture, not just keep resetting it.
And physically check the cover itself.
Yes. Does the spring mechanism still create a tight seal? Is the foam gasket behind the plate still intact and pliable? If any of those defense layers are compromised, they need to be addressed immediately.
And maintenance also includes managing the power flowing through them. We often forget the load we put on these circuits, right? Power tools, high wattage lighting.
That's circuit management. And it's so important. You absolutely must avoid overloading outdoor circuits, particularly around the holidays or during a big spring cleanup with multiple tools running.
Why is that combination so dangerous?
Overloading increases the temperature of the wires and the components. When you combine that excessive heat with moisture, which reduces resistance, the risk of a localized electrical fire just increases dramatically. You have to know your system's limits.
Which leads us to the practical financial side of this. If someone needs to buy their outlets up to code-mandatory GFCI compliant covers, what are the general costs they can expect for just the hardware?
The hardware itself is actually quite manageable. Safety is accessible. Our sources detail specific cost ranges. GFCI outlets, they're a bit more complex than standard ones, so they typically run between, say, $10 and $50.
Depending on the brand and features.
Right, brand, tamper resistance, things like that.
And the essential weatherproof covers, the in-use ones.
Those generally range from about $5 to $25. So for the materials to upgrade a single outlet, you're looking at under $75. But the listener has to factor in potential labor costs. If you're replacing an older outlet that requires some new wiring, or if you need an electrical panel upgrade to handle the modern demands safely,
then those costs can be an additional expense.
They can. That's where expertise becomes necessary. Not just for the installation, but for ensuring the whole underlying system can handle the new load and meet the code.
Which lets us leverage the second source material you provided. This one speaks directly to professionals who specialize in the safety and compliance upgrades.
That's right. That source introduces Copperfield Electric, and their services align perfectly with the protective measures we've been detailing. When you move from an old, inadequate outlet to a mandated GFCI system, you really need a licensed expert.
So what are the key facts about Copperfield Electric, particularly regarding their reliability and expertise in handling these very specific home safety requirements?
Well, they're noted as a family-owned business specializing in comprehensive electrical services. Critically, their service list includes home safety outlets installation, which is a direct reference to what we're talking about.
So ensuring GFCI and compliant outdoor systems are correctly installed.
Correct. They also handle electrical panel upgrades and general troubleshooting. This confirms they can do more than just swap an outlet. They can ensure the entire circuit and panel can safely support the system.
And what about credentials and availability? That's vital when you're inviting someone into your home for safety work.
They operate as a licensed, bonded, and insured company. Their license number is noted as #10944740. And they prioritize trust. It says all their electricians are background checked.
And for emergencies.
Crucially, they operate as a 24-hour electrician. They offer 247 emergency services.
Which is when these things often happen, right? During a storm, outside of business hours.
Exactly. When a circuit trips repeatedly because of moisture, you need someone who can respond.
And for our listeners in the region, where exactly does Copperfield Electric focus its service?
Their service area covers Southern California, with a heavy emphasis on Orange County. Specific areas mentioned include Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, Laguna Beach, and Mission Viejo.
So they are the precise experts needed to address the code deficiencies we've outlined?
Sorry.
This has been an incredibly thorough deep dive. So let's summarize the 3 core protective actions to weatherproof your outdoor power and keep your family safe.
First, install those NEC-compliant extra-duty weather-resistant covers. That's your robust physical shield. And make sure it protects the connection even when a cord is plugged in.
Second, ensure that GFCI outlets are in place. That's the immediate life-saving detection system, monitoring for that tiny 5 mA current imbalance that signals danger.
And third, practice diligent long-term maintenance. Inspect those outlets and covers regularly for wear, rust, or corrosion, and immediately replace any damaged components to maintain the integrity of that first line of defense.
If you follow those 3 steps, you move from a vulnerable system to one that meets modern safety standards.
You know, this raises an important question that builds on everything we've covered.
What's that?
If you currently rely on an old, non-compliant, simple flip cover outlet. Maybe it's tucked under an eave. And you replace it with a mandatory GFCI outlet, but you fail to upgrade the physical cover.
Okay.
Are you creating a false sense of security that encourages you to use power in wet conditions? Or does the instant tripping of the GFCI ultimately negate that failure entirely? It's a challenge to recognize that safety is only as good as the weak link in the chain.
A great thought to mull over. Ensuring safety requires redundancy, but also recognizing that redundancy doesn't excuse carelessness. That's all the knowledge we're extracting today.
Until the next deep dive.